Move your slides.
You move so that I move. Go on. Code and presence. Rocking data like it's 1979. If you don't know for sure, those are both albums by Ned Zeppelin. Yeah, because this picture, like, it reminded us of how we first felt when we started working on this, because like most people kind of had their huge crash with the Coda system and on how to access the data properly, and that's what we want to address. We want to make the Zeppelin fly again. We want to make it really easy how to access the data and make it intuitive and also actually more fun to work with it. So then people get more motivated to improve with maybe more visual and more amazing applications. So I will kind of skip the part on how it was before because the other group already very detailedly explained that. What our solution to this is, we have this system that's built up upon the Coda API. So before you see a very grayed out on there those two XML queries and this URL, you need to get those manifest files in order to know where the files lie that you actually want. And we represented this with some Python classes. So first we have the query class that's actually very easily used to generate a query where you type in your search parameters and then it returns you all IDs for the products you actually want. And then you can just make a product class out of this, and from this product class that actually gives you a very easy access to all the file names, and then you just select by get file name the file you actually want, and then it gets downloaded. What we also want to, what we also have in here, but it's not represented in the diagram yet, is that we also have this possibility of slicing up files. But we had some maybe different approach to it, because we just simply took all of the points that were relevant in the bounding area and remapped them into a new set. Because what we had seen in the previous picture was that it was kind of angled in this screen, and we wanted it so you always get the correct rotation. But obviously it's not perfectly working yet. This one.
Okay, so let's take a look at how it works. I have a demonstration notebook here that's on GitHub, and I'll pull that over here. So you're going to have to put on your reading glasses. Okay. You can take them off then. Everybody stay calm. This will resolve itself in due time. Okay, so if you were to be seeing, there we go. So this is actually the documentation that's linked to on GitHub. It's available as a notebook, as a gist. So this isn't on my laptop, it's on the web. So you start off wanting to access data about a certain, that's picked up by a certain instrument, it's a certain level product. And in order to do that, all you have to do is import Coda Presence. Well, first of all, you install Coda, so you can do that with this line here. It's on Python Package Index, so you can do it right now. And then you create a query. You say what product you wanted to query. You put in, for example, here I have a temporal bounding box, so from the beginning of the data that I want to see to the end of that, and I don't have a spatial limitation on that. And that becomes a query. And you can do the same for any other product, and then you grab the UUIDs that are associated with that with the get UUIDs method. And this is also associated with the option to restrict the number of responses that you want to get. As you can see here, you get a lot of security messages saying the security with the website you're talking to is bad, and our Coda Aware class ignores that neatly so that you just get the UUIDs that you want. So here are a bunch of UUIDs, for example. And if you wanted to actually do some work with that, then you can feed it into a product, which is right here. So here I'm putting in the first UUID that I found, and I'm going to cache files in my temp directory on my laptop. And so the first thing you can do is, what it does is this actually talks to the server, finds out what nodes are associated with that product, and then caches a list of the resources that you could ask for. And so you can see here, after talking to the server a bunch, these are the files associated with this product. And then at the end, we don't have a visualization. What we do have is, you can see, you have this call olci get, and you ask for a specific file from that product, and it returns it to you, either by downloading it or just by giving it straight up back to you. So that's pretty straightforward. Like the other project, it's also available on GitHub and on Python Package Index, so you can start working with this today. It's with an MIT license. So what could you use that for today? If you are going to work on data right now, and you don't want to deal with the APIs, and you don't want to be clicking a lot, then you can already use this. It's also useful if you know that you're going to be working with data, but you're not sure exactly how much data you'll need, but you don't want to download too much, and you don't want to wait, on the other hand, for the data in the second that you need it. This will streamline that process. Maybe you want to share data with your friends, and they're probably going to want the same data as you. Also easy, you just share a cache. So it has to be a local cache, though. But if these are all things that describe your use case, then you have no problems. You can work with our package as is. For the future, I put together a little estimate how much work we would need to make it really usable in a more scalable sense. Something I'd like is for it to be more configurable for better security. I'd like to put a WCS adapter on it so that you could have more, you wouldn't have to use a querying dialect that we have in there. You could also address it via REST API. And then I'd also like to write an S3 adapter so it uses cloud storage and not necessarily local storage only. Serverless deployment of Beanstalk would make it highly available, and you wouldn't have to worry about deploying it on your own machines, and etc. And for simple post-processing, like chopping, slicing, dicing your data, you could associate that with the buckets with lambdas. So that way, whenever the data is pulled from the Coda server, you can automatically get it into the format that you want it in. And I believe that you could do all of this in under 2 days quite easily. And if you would like to do that in under 2 days, you're welcome to. You can install it with pip and start working on it right now. You can fork it on GitHub. You can steal it because it's with an MIT license. Have fun with it.